Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over a couple more problems from the Topical Review Worksheet 8 on Basic Trigonometry. So I'm told on number 7 that an angle is drawn in standard position and its terminal side passes through the point 4, -6. So the x-coordinate's 4 and the y-coordinate's -6. Find the exact value of all 6 trig functions in simplest radical form. So the first thing you're going to do is create an x and y axes. The fixed side of the angle lies on the positive side of the x-axis. That's always the case. And the terminal side is going to rotate until it hits the point 4, -6. Well, 4, -6 is in quadrant 4. So I'm going to draw that point, and from the origin to that point, I'm going to make a ray or a radius, and from that point to the x-axis, I'm going to make a perpendicular line and form a right angle. Now, the horizontal side is your x, and so in this case it's 4, and the vertical side is -6. I can find the hypotenuse by using Pythagorean theorem. So I have 16 plus 36 is equal to c squared. 52 is equal to 6c squared. C is equal to plus or minus the square root of 52. Because it's the hypotenuse, it's always positive, and I can simplify square root of 52 further into the highest perfect square and the other number. 4 times 13 is 52, 4 being a perfect square, so c is equal to 2 square root of 13. Okay, so now I want to find all the trig functions. So sine of theta, we think SOHCAHTOA. I'm going to write that down here. So sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And TOA is opposite over adjacent. And those are some basic properties you really need to know for a very long time. The hypotenuse is across from the right angle. The adjacent side is the x. It's adjacent to the angle, and the angle is always formed between the closest portion of the x-axis and the hypotenuse, and this is the opposite side. So sine, being the opposite over hypotenuse, is going to be -6 over 2 rad 13. Now, we're going to have to rationalize this, but we're going to rationalize at the end. Also, we can simplify this further. 2 goes into -6, -3 times, so this could be simplified to -3 over rad 13. Leave some space, and I'm going to now find the cosine of the angle. Well, the cosine is the adjacent side, which is 4, over the hypotenuse, which is 2 rad 13. And the 4 is divisible by 2, so this simplifies into 2 rad 13. And again, we'll rationalize it at the end. You'll see why in a moment. And tan of theta is opposite, so -6 over hypotenuse is 4, and so that simplifies to -3 over rad 2. So now I want to find the reciprocals. So the reciprocal to tangent is cotangent. So it is adjacent over hypotenuse 4 over -6, which simplifies to 2 over -3. But if you know tan is -3/2, you can just flip this over. And again, these formulas you need to memorize, right, for a long time. So a reciprocal just means you're flipping that fraction. So you can either flip the opposite over adjacent and calculate adjacent over opposite and then simplify, or if you have tan first, you just take the reciprocal. The reciprocal of sine is cosecant. I'm moving it over because I want to have room to rationalize sine of theta later. And again, you can either work directly from the triangle. Secant is, if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So that would be 2 rad 13 over negative 6, or you can just flip the sine fraction. And that's a little bit faster, so that's what I'm going to do. Okay, now I'm going to go to cosine. The reciprocal of cosine is secant of theta. So secant is adjacent over hypotenuse, so secant is hypotenuse over adjacent, so 2 rad 13 over 4. That's one way of doing it. Or if you already know cosine, you can just take the reciprocal of it. Notice when sine's negative, cosecant's negative. When cosine's positive, cosecant's positive. When tan is negative, cotangent is negative. Okay, now this is almost done, except we do have to rationalize. So if I want to rationalize, and the only ones we have to rationalize are sine and cosine. So I would multiply this by rad 13 over rad 13. And that simplifies that radical. So that becomes negative 3 rad 13 over 13. So that's just the sine of theta in rational, with a rational denominator. And likewise, cosine, you would do rad 13 over rad 13 and get 2 rad 13 over 13. Just for your information, sometimes they request that you rationalize and sometimes they don't. So that's question 7. I was asked to do 8 slightly different with all students take calculus. I'm going to do that now. And I'm going to make an X and Y axes. And I'm going to graph that point. Now that point is XY. And when you have both negative, that's in quadrant 3. So here's that point. From that point, I'm going to draw a perpendicular line to the x-axis. And from the origin to that point, I'm going to draw my radius or my hypotenuse and form a right triangle. I know it's a lousy right triangle. Please forgive me. And here's my angle theta, and I'm going to label the sides. So this is -1, and the vertical is -2. And now I want to find the hypotenuse. I'm going to do that with all students take calculus again. So this with Pythagorean theorem. So this is -1 squared plus -2 squared is equal to c squared. 1 plus 4 is equal to c squared. 5 is equal to c squared. C is equal to square root of 5. Because it is the hypotenuse, you only have the positive version. Normally you would have plus or minus. Okay, next, I want to find the sine of theta. So sine of theta is opposite. Let's just write SOHCAHTOA down. So sine is opposite over hypotenuse, and that's -2 over rad 5. Therefore, cosecant is rad 5 over 2. Cosine is adjacent over hypotenuse. So secant is negative rad 5 over 1. But when something's over 1, Just when one's in the denominator, you would not write it. And then finally, we want to do tangent. So tangent is opposite over adjacent, and that just simplifies to 2. Cotangent would be the reciprocal. So that would be 2 over 1. And again, when you just have 1 in the denominator, you wouldn't write it. I see a tiny mistake. I forgot the negative here, so I'm just going to put it there. I just want to mention something. You can verify these results with the signs, positive and negative, by all students take calculus. So we know that we're in quadrant 3 and only tan is positive, therefore sine and its reciprocal are negative. So sine's going to be negative, and you see cosecant's going to be negative. In quadrant 3, cosine's negative, right? Only tan is positive and it's reciprocal. So notice cosine's negative and secant's negative. And finally, tan is positive in quadrant 3, and so is its reciprocal. Okay, number 9, find the rotation, for the rotation 665, find the coterminal angle between 0 and 360, the quadrant that the angle is in, and the reference angle. So this is more than 360. And so when that happens, to find the coterminal angle, if it's over 360, you keep on subtracting 360 until you find an angle between 0 and 360. And so we do, and we get 305 degrees. Make sure if you're in degrees that you add a degree symbol. Well, that angle lies in quadrant 4. And to find the reference angle, one, you can do it by just looking at it. Here's the angle of 305 degrees. The reference angle is formed by the closest portion of the x-axis and the terminal side, so it's that angle here. And that's just taking a full 360 and subtracting the angle, and that's 55 degrees. The other thing you could do is use, from way back when, that chart for reference angles. So if your angle lies in quadrant 1, the reference angle is equal to the angle. If your angle lies in 2, the reference angle is the angle minus 180 degrees. If you're in quadrant 3, it's the I have a mistake here. No, I don't. This is theta. This is 180 minus the angle. I did have a mistake. So if you have 120 degrees, the reference angle would 180 minus 120, or 60. When you're in quadrant 3, it's the angle minus 180. So if it was 210 degrees, the reference angle would be 210 minus 180, or 30. And like I mentioned before, in quadrant 4, it's the 360 degrees minus the angle. So just putting that back in your mind, and that's to find reference angles. The other thing you need to remember is the special angle chart. So this is 30 degrees, 45 degrees, 60 degrees. You have to memorize the special angles, and then it's sine of theta, cosine of theta, tangent of theta. Remember, sine divided by cosine is tangent. If you recall, the first 2 rows are over 2. And then notice it goes 1, 2, 3. So it's 1 square root of 2 square root of 3. And cosine's the opposite. Square root of 3 square root of 2, 1. Anything divided by itself is 1. So sine divided by cosine is 1. This is rad 3 over 3. And tan of 60 degrees is just rad 3. Notice that the smaller angle is smaller. It's the 1 divided by 3 for tan. So how is that helpful? Sometimes we're asked to find the exact value of a trig function. And so if I have sine of 120, instead of figuring out the whole thing, I can bring it down by finding the quadrant the angle lies in, whether or not sine is positive or negative in quadrant, whatever quadrant it's in, the function, and the reference angle. So sine of 120 is in 2, so the angle lies in 2. And then you would go, all students take calculus. So when you're in quadrant 2, sine is positive. The function is sine. And how do you get your reference angle in 2? Well, let's draw it out. Here's my reference angle. To get it, it's going to be 180 minus the angle, which in this case is 60. So sine of 120 is equivalent to sine of 60, and sine of 60 is rad 3 over 2. Now we're going to do cosine of 495. So you're going to subtract 360 from it, because you want to find the coterminal angle, like we did before. And so cosine of 495 is the same thing as cosine of 135 degrees. Don't forget the degree symbol. Almost forgot it there. So now I'm going to use Lucifer. And Lucifer is just a gimmick to help you remember and organize your thoughts. So 135 is in quadrant 2 again. Cosine, think about it. All students take calculus. Only sine is positive in quadrant 2. Therefore, cosine and tangent and all the reciprocals of cosine and tangent are negative. The function is cosine. And to get the reference angle, again, it's in quadrant 2, so it's 180 minus 135, or 45 degrees. So this becomes negative cosine of 45 degrees, which is negative rad 2 over 2. And now we're going to do tan of negative 120. When you have a negative angle, in order to determine everything, you want to find the coterminal angle. With the negative angle, you add 360. You get tan of 240 degrees. And now we're going to do Lucifer again. Again, it's a gimmick just to help you remember. So 240 degrees is located in 3. Let's do all students take calculus. So in quadrant 3, tan is positive. So this function is positive. The function is tan. And to get the reference angle, when you're in quadrant 3, right, I'm going to draw it out so you see it. So here's the angle. To get the reference angle, again, that's the terminal side with the closest portion of the x-axis. You're going to do the angle minus 180, and you're going to get 60 degrees. So tan of negative 120 is equivalent to tan of 240, which is equivalent to tan of 60. And if you look in the special angle chart, tan of 60 is rad 3. What are the reciprocal functions? We know secant of theta, you're going to memorize, is 1 over cosine of theta. We know cosecant of theta is 1 over sine of theta. It's kind of opposite of what you expect. And cotangent of theta is equal to 1 over tan of theta. And these are, again, things that you have to memorize and use for a long time. Tan of theta, those are the quotient functions, so think dividing, is sine of theta over cosine of theta. And cotangent of theta is the reciprocal, so its quotient function is cosine of theta over sine of theta. And I will do another video later this week on worksheet 9. Hopefully that helps. Have a nice day.